we will see how quicksort algorithm works. There are 9 elements 3, 7, 8, 5, 2, 1, 9, 5, 4 in this array. I have to sort using quicksort. I have written here the algorithm, and main algorithm is this, the of quicksort. Quicksort, we will take input in the main function of any array, and we will pass that array with its low and high index. Here low is what? Low is its first element position, and high is last element position. So through main function, this array, its starting index and last index has been passed. So this quicksort algorithm is simple. Here just we have to compare low. If low is less than high, that means always it should be lesser than, then only function will proceed. If function will terminate, and our main algorithm will be complete. So if low is less than high, then we have to use one more function, partition. Partition, what we will pass here, array, a starting index and last index, and then there will be two array created after partition, quicksort. So we will call two quicksort function again. Just see how does it work. I show through example, then we'll understand this algorithm. So what array has been given? 3, 7, 8, 5, 2, 1, 9, 5, 4. So at first pivot we have to take the last element. So here 4 will be pivot. This is the last element. Now what we have to follow, we have to actually mainly use partition function. So what is your partition function? Here array, a starting index, this is also first starting index of the array, and high will be last index. So here the 0, 1, 2, 3, 4, 5, 6, 7, 8, these are the index. So see the partition function, what it has been, we have passed this array. So what will happen according to partition function? Or just see at first how does quicksort will work. Here see pivot, what does it do? It always selects all the elements which are lesser than pivot. So whatever are lesser than pivot will be on the left direction, and which are greater than the pivot, all are will be in the right direction. So after first partition function, what will happen? 4 will be on its exact sorted place. This pivot, this is pivot. That means after first partition, this pivot will be positioned on its correct sorted place, because all the elements on left of pivot are lesser than this, and all the elements right of the pivot are greater than this pivot element. So that means 4 is on the correct position. So whatever array will be on the left side of pivot, all will be lesser, and whatever element are on the right direction of pivot, all will be greater than pivot. So here 4. So whatever elements are lesser than 4, all will be in the left direction, and whatever elements are greater than 4 will be in the right direction. So this pivot will place, this partition function will place the pivot on its correct position. How will it place on the correct position? Just see this algorithm, just this function. We can randomly do here also, but this will be the correct way if we follow this function. Okay, so just see here, so it will be better to understand also, because see, now if we take here, what will happen? 3 is less than 4, this is less than 4, 2 is less than 4, so and 1 is also less than 4. So all this should be on the left direction of 4 and 4 should be here, and whatever are greater than 4, those should be on the right direction. So I'm just telling randomly, not according to this partition function. 7 8 5 9 5, this should be like this. See, all are which are lesser than 4 in the left direction, and all which are greater than 4 are in the right direction. So this will follow for this array also and this array also. That means this was a complete array. So one pivot function has been, one partition function has been called and pivot has been created. Again, two array will be created, and for those again this will be pivot, and for this 5 will be pivot. So again this function will be called, and this will be here pivot will be positioned on its correct position. But now we see the algorithm, how does it apply here. Okay, so what is here, all the elements 3 7 8 5 2 1 9 5 4, its index I take 0 1 2 3 4 5 6 7 8. See here, according to this, first we have to select I. Here this will point to low and this will point to high. So here low is equal to 0 and high is equal to 8. So I we will initialize with low minus 1, that means 0 minus 1, this will be minus 1. And pivot will be array 8, this will be 4. Now we have initialized I with minus 1 and pivot is last element, that means for array high. Now this will go in this for loop. So what is here, j have to start with lowest index and go with high index, that means 1 before high index, because here see this j is last element index, but according to this for loop this will go just before one less element of that last element index. So this will go from low to high minus 1, because see pivot what we are doing, we will see here pivot here we are swapping on outside of that for loop. See for loop is coming till here only, and this is outside of for loop. So we have swapped here pivot outside of this for loop, so no need to go till pivot. Now see, we will start from j. J is pointing to lowest index, so j will here at first point to 0. J will start from 0 and it will compare with pivot. Pivot is 4, so 3 is less than 4, yes. Here I is also minus 1 and j is equal to 0. So array 0 is 3 and 3 is less than 4. So here according to this function for loop, here I will be increased, so I will be 0 and we have to swap with array j. Array j, that means 3, and array I. Array I is what here, 0, that means both are pointing to same, because see I equal to 0 also and j equal to also 0, so both are same. So that means after first swapping what will happen, 3 will be on the same position, and 3 7 8 5 2 1 9 5 4, here j equal to 0. Now j will go to this 7, j equal to 1, this 7 is 1 position. 7 is less than 4, no, so nothing we have to do. 8 is less than 4, no. 5 is less than 4, no. I is still pointing here, you just remember. Now j will go on this 2. 2 is less than 4, yes. So what is here j? 0 1 2 3 4. J equal to 4, I is still 0, and here 2 is less than 4. So according to this function what we have to do, we have to increment I value by 1, I will be 1, and then swap this array I with array j. That means array I, array 1 is 7, and array j value is 4. That means this is 2. So we will have to swap this 2 with first index element. So after swapping, what will happen? 3, 2, 8, 5, 7, 1, 9, 5, 4. Okay, swapping done. Now again next j value will be incremented 5. So after 2, this 5, j will come here. 1 is less than 4, so we have to proceed. And I is still, I has been incremented to -1. Now I will point here. See, I will point here. I equal to 1, not -1. Okay, I is pointing to 1. And j is 5. That means this one. J is here, I is here. So what we have to do, we have to increment the value of I. So I will be 2. And then we will do swapping with array 2 to array 5. So array 2 is here 8 and array 5 is here 1. So both will be swapped. So after swapping, what will happen? 3, 2, 1, 5, 7, 8, 9, 5, 4. So I is still pointing. Now I is pointing to 0, 1, 2. That means this index 2. And j will go to sixth index. So 9. 9 is less than 4? No. 5 is less than 4? No. So now for loop will be terminated. So after termination of for loop, what is there? We have to swap I plus 1, array I plus 1 with array I. So here I value is 2. So we have to swap array 3 with array I. Array I, that means last index, that is 8. So both will be swapped 3. Because after this swapping, what will happen? 4 will come on its correct position. 3, 2, 1, 4, 7, 8, 9, 5, 5. See, this quicksort is unstable algorithm. Unstable means, that means whatever position of those elements, that means here 5, what happens? It has gone on next 5. That means both 5 are on its relative position, they are not maintaining, because 5 is equal to 5, so they should maintain the position, but it will not maintain. So this is unstable algorithm. So what will happen now? All the elements which are lesser than 4 in the left direction, and all the elements which are greater than 4 are in the right direction. So there will be 2 array again formed, and 4 will be in its correct position. So now we will start again sorting like this. We will do partitioning and call 2 quicksort function, because first quicksort function this will be called, and this again second quicksort function this will be called. So here low will be 0, 1, 2, and here partition index is what? 3. 0, 1, 2, 3, 4, 5, 6, 7, 8. And for second array, low will be 4 and high will be 8. First array, low will be 0, high will be 2. So again we have to do partitioning accordingly, and we will put pivot on its correct position. So what will happen? I just show by diagram. Now just in the same way like we have done, we will do that partitioning. I just show by diagram how will this happen. That means 2 array has been formed, 3, 2, 1, and here 1 array 7, 8, 9, 5, 5. So what will happen? Here this 1 will be pivot, and here 5 will be pivot. See this one at first. So 1 is less than 3 and 2. So what will happen? 1 will come on its correct position. You can do using that partition function. So 1 will come here, and 2, 3. So this will be on its correct position. So 2 and 3. Only here 1 array will be formed, because on the left side of 1 there are no array. So if it is called, this is no arrays, so nothing will be called, and then we will do its partitioning, and 3 is now pivot. So it is in correct position. So 1 here, 2 and 3. 1 is already on sorted on correct position, and after this 2 and 3 this will be sorted. Here how will it happen? 7 8 9 5 5 5 we have to bring at some at such position, that means all the left element of 5 will be smaller and all the elements greater than 5 will be on the right direction. So 5, that means what we were checking in this partition, if any element is less than pivot then we have to swap, and lastly we will swap with last position to I index. So I was what? Low -1. So if we see here, it was pointing 0 1 2 3 4 like this. If we do, or do just according to this index, real index. Here index is 4 5 6 7 8. So here I initially was 3, but after coming of for loop, because no element was less than 5, so I will become 4 and this will be swapped with 5. So after swapping, what will happen? 5 7 8, sorry, not 7 here, 5 8 9 5 7. See, 5 will be swapped with 7, 8 9 5 will be on the same position. So this 5 is now on its correct position. So all the elements which are lesser than 5 will be on the left direction. So no elements are lesser than 5, so nothing is in left direction, and all elements which are greater than 5 will be on the right direction. So its index is now 5 6 7 8. See, now we have to swap this element, this array, 8 9 5 7. So 8 9 5 and 7. Now we will take 7 as pivot. So what we have to do, whatever elements are less than 7 will be in the left direction, and whatever elements are greater than 7 will be on the right direction. So here index was what? 5 6 7 8. Initial index was starting from 4, low -1. So now what will happen according to partition, it will be compared. So we will see now here 5 8 is less than 7, no. 9 is less than 7, no. 5 is less than 7, it's coming. So what will happen? 5 will be swapped with first position because I will be incremented 1. So this 8 and 5 will be swapped. Because initially I was pointing to 1, so I will be increased and it will point to 5, and then this 5 will be swapped with 8. So what will happen after this swapping? 5 9 8 7. So I was pointing here. Now after coming of for loop, what will happen? I will be incremented 1, so both of these will be swapped. So after swapping, what will happen? 5 7 8 and 9. That means 7 now has come on its correct position, this pivot. So which are on the left direction, those are smaller than 7, and which are on the right direction, those are greater than 7. So its index was 5 6 7 8. So there is only one element 5. This is already sorted, single element is already sorted, no, nothing to sort here. Now see what we have to sort: 8 and 9, 7 and its index are 7 and 8. So we have to swap 8 and 9. 8 is less than 9, yes. Here I will be started with 6, and then inside of for loop I will be incremented 1, so I 7. That means array of index 7 will be swapped with same element, because here j was pointing to, j will start from pointing to 7. So here 8 will be swapped to 8 only, 9. And after coming of for loop, what will happen? I will be pointing to this same index, and I is also same index. So 8 and 9, that means 9 will be swapped with 9. So this pivot, that means 9 has come on its correct position. So whatever elements are less than 9 are on the left direction, and whatever elements are greater than 9 are on the right direction. So see from below what happened: 9 8 7 5. Till 5, 4 elements were there for after initial pivot. No, see here 8 9, after this 7 7 8 9, after this 5 and again there was one more 5. So 4 elements, 5 elements were more than 5 here, 4, see, and 3 to 1, 3 to 1 here it has already sorted, 1 2 3, 1 2 3. So this is sorted. So this has been sorted from quicksort using quicksort algorithm. Let's start quicksort function algorithm. I have already explained about its working. Now see its code. How will it run in the program? Okay, so at first we will define main function. If name equal to main, I will take at first number of elements as input. So print enter the number of elements. N is the number of elements, int input. Then I will define the array where all the elements will be given as input. Now print enter the elements. I will go inside for loop for I in range 0 to n. I will take one element as input and I will append them in array this yearly. Okay, now array has been defined, array input has been taken. Now what I will do, I will call the main quicksort function. So I will define quicksort and I will call with array starting index 0 and last element index is n minus 1. That means last index will be n minus 1. We have to call using a starting and last index, not total number of elements. So it will be called, and after calling I will print sorted array is okay. Again for this for loop print array I and equal to I. Okay, so see, now we have what we have to do. I have to create this quicksort function. Quicksort, I will define here array and a starting index with low and last index will be high. Okay, here define this keyword. Without keyword this function will not be defined. So what I have to check, if low is less than high, that should always be. Then I have to find out partition index, that means pi. Here I will just create one another function, partition array low and high. And after creating partition, what partition index will be here. So I will again call, because after partition there will be two array created, so we have to again call 2 times this quicksort. First will be, it will be called for array low till one less index than partition, that means pi minus 1, and again this quicksort will be called for after partition index pi plus 1 and high, its last index will be high. So this is the main quicksort function. Here it's nothing. We have defined one quicksort function. We have passed array starting index low, last index high. So if low is less than high, we have created one partition index using partition function. We have called array low high, and we have again called two function, because two quicksort function, because there will be two array created after partitioning. Now define this partition function. Again here array low and high. What I have to do here, actually on the quicksort na main thing is in partitioning. If you have understood partition algorithm, partition function, then complete quicksort is very easy, because in this quicksort we are nothing doing, we are just finding on, we are just calling. Here in quicksort function there is only calling, nothing is there. We are calling partition function, we are calling again quicksort, we are again calling two times only quicksort. So main thing will be done inside this partition function. So here what I have to do, I have to just take one lower index than low, a starting index. So I will be low minus 1, and I have to do pivot. I have already told we have to do, and what will be the pivot? Last index. So pivot will be last index of this array. So array high. Now we will start from first index till second last index, because last index is already pivot, so we have not to go till last index. So for j in range low to high, that means it will go till high minus 1. Here we have to compare with this element array j to pivot, because I have to bring pivot on its correct position. If array j is less than pivot, then what I have to do, I have to increment once time I value, I have already told, and we have to swap array j with array I. So array I, this will be swapped array j. Actually there is, in Python there is no need to use a temporary variable, it will be directly sorted. Array j to array I. See here, array I will be equal to array j, and array j will be equal to array I after swapping. Now we will come outside of this for loop after proceeding this process, and we will swap last index with I plus 1 index. Array I plus 1, array I, that is the pivot, it will be swapped with array I to array I plus 1. That means whatever element is present on I plus 1 position, it will go on highth position, that means on the last index. So that will again work as pivot for another array. And what I have to do, I have to return the partition index. So what will be partition index? I plus 1. Because on I plus 1 only partition element has come, that means pivot element has come. Whichever was pivot, it has come here, I plus 1 index. And whatever was pivot position, that has been gone from I plus 1 position. That means see, array I plus 1 has been become to equal to array high, that means this has been swapped with array high, and array high has been become equal to array I plus 1. So now this is complete function of quicksort. Hope it should work. Just see once more time. I have defined here main function. I have taken input as the number of elements in n. I have defined again array, enter the elements, fine. Again I have called quicksort function. Okay, then I have printed all the elements. Here quicksort function has been called. If low is less than high, then we have to find out the partition index, array low high, then we have to call 2 times quicksort for both the array low pi minus 1, array pi plus 1 high. And this is the partition function, array low high. I have started with low minus 1, pivot is last index element. For j in range low to high, if array j is less than pivot, I will be incremented once time, and array I will be swapped with array j. And after coming out of for loop, last element will be swapped with whatever ith position is there, and by to increment that once time, that will be the partition index. That means pivot will come on that position, and then I will have to return the partition index. Okay, now run this program. Enter the number of elements. How many elements? Let's do at first 4 elements. Okay, enter the elements. I just enter all 4 in descending order. 3 2 1. There is coming one error. What is this one? In 13th line, 26th line also, array 0 n minus 1. N was int input, fine. And 13th line is what? 13 partition low high. Partition array low high. What is here? Name partition is not defined. Okay, partition spelling is wrong. P-R-T-I-T-I-O-N. P-R-T-I-T-I. Okay. Here. P-R-T-I-T-I-O-N partition. No. P-R-T-I-T-I-O-N partition. Okay, again run. Number of elements 4. 4 3 2 1. Sorted array is 1 2 3 4. Again we can take large element. I will take 5. That means random value. Okay, 6 elements. 67 45 89 23 4 95 12 6. Now see sorted array. 12 23 45 67 89 90. This is sorted. So this quicksort algorithm is working fine. So thank you.